Welcome back, everyone. See, that wasn't too bad, creating VLANs, assigning VLANs. Very simple, very simple. Just always remember to trunk those ports between switches. But when you do, something happens. And this is where it leads us to the spanning tree protocol. What is spanning tree? The purpose of spanning tree is to avoid switching loops. A switch, by nature, since nature created it, it will continue to forward and forward and forward and nonstop. And as network techs or engineers, whatever title you want to give yourself, all right, the forwarding of these bridge protocol data units going around all these switches, it's not a good thing because it will cause a broadcast storm. And we all know that. What that means, a broadcast storm means that your network will fall down to its knees. It will die literally on you. But let's take a look in the packet tracer. So take a look at spanning tree in action, right? So we don't need crossover cables. I'm going to be lazy. I'm just going to use that lightning bolt. So you can pick, it usually picks the first ports anyway. Gotta hit them right on the blue. All right, when you see these lights that are turning amber, we got two switches. I know it was right behind me, so you couldn't probably see it. All right, we got two switches. You see that span tree is thinking about it, saying, what's going on here? We got redundant links. That's when span tree becomes alive, when you have redundant links. And it takes about 30 all the way up to maybe 90 seconds for it to make a decision. And we'll talk about that in a future lesson. But for right now, you can see that these two lights are green. That third light up there is green, but one light, it's amber. It is amber. So I can tell you right now for the terminology that you need to understand about span tree. So now you know span tree, its purpose is to block switching loops, right? Stop switching loops. How does it do that? It blocks a port. There it is. That's your block port. It stayed amber. Doesn't mean it's not listening. It still receives, but it will not forward. All right. But let's take a look at this first switch right here. All right. Let's put this over here. You know what? Let's just maximize it. And the way you look at it, you go to privilege mode, obviously, show spanning tree, and you take a look at it. Now, one of the things that you want to pay attention to is, hey, this is telling you it's the root bridge. And we'll get into the election process later. But this is the root bridge. That means that on the root bridge, all ports are designated forwarding ports. Designated forwarding ports. And you see, since we're using fast Ethernet, the cost of that is 19. The cost of it is 19. If we're using gigabit, it would be 4. All right, so any port on the root bridge will be a designated forwarding port. All right, that's what you need to keep drilled in your head, meaning it will forward out information. Okay? Designated forwarding. This is the root bridge. Okay. So I guess we're going to go to the non-root bridge, which is the bridge that's not the root. Pretty simple, right? Don't got to get complicated with it. Show spanning tree. And here, hey, this is not the root bridge. Okay. So, but what are we looking at? Hey, there's the port that it blocked. See? Alternating block. And then there's a port that says root. All ports that face the root bridge are root ports. They will forward. Obviously, you can see the status of it is forwarding, but it's a root port because it's facing the root bridge. Now, this is a very simple example. This is just so you are aware of the command to look at spanning tree, which is show spanning tree. All right, or show spanning tree VLAN 1, because this is the only VLAN we have for now. All right, but once you see the amber light, and what they'll do on your test, they'll ask you to pick the root bridge, They'll ask you to pick which port is designated forwarding, or which port is block port, or which port is a root port. So these are the things you need to be aware of. So remember, on the root bridge, all ports are designated forwarding. They will forward information. On the non-root bridges, right? Like in this scenario anyway, you'll have one block port and the other one will be a designated forwarding port. It will forward information. Always remember, the block port will just block from PDUs being forwarded, bridge protocol data units from being forwarded, but it will receive. It will receive, but it just won't send. All right? That, ladies and gentlemen, is what STP is. In our next lesson, though, we're going to break it down and make several comparisons and take a look at the election process of Spanning Tree. I'll see you there.